Hi, children. It's great to see you. Thanks for coming to the party. Got some work to do. Go listen to math videos. Math videos are awesome. Love them. My name is Mr. Krause. You can call me Mr. Key. Wow, that'd be really boring. Oh my god, that'd be so boring. I'd be like, no, dude, can't watch you. You're going to put me to sleep. It's already boring enough. Hey, 2.5 homework 2020. Yes, I'm enjoying this weekend because I don't have to wear my mask that much, which is quite awesome. All right, let me blow this thing up. Let me max them out a little bit here. Here we go. Let's go. Little review from yesterday. So one thing you're at first place you want to look is right here, right? If you don't see anything, then we're talking about square roots. Okay, square roots. Square roots are the only things that would have eyes in them. Okay, so actually we're doing the same problem 3 different ways. So the square root of 81 is fine. We can rewrite it as 81 because that's a perfect square. X squared, y squared, y, and then z to the 4th. Remember, we want as multiples of 2. In this case, we want evens, right? So let's see. Cross u out, you are 9. Cross u out, it's x. Cross u out, that's y. And cross u out, that's z squirt. And the only thing I didn't cross off was this little y right here, and that's it. Now we're going to do the same problem with cubes. Now, nice thing about 81 is there is a cube. 81 is a square. There is a cube in 81, and 81 is a 4th. Did you know that? So remember, cut it in half. That's 40. And the first perfect cube under 40, is 27. 27 times 3 is 81. Can't do anything with x squared because you have to write it as a multiple of 3, but we can't. Y cube's already a multiple of 3, so we'll just leave that. And then z to the 4th, we're going to write as z cubed times z. So we want it as a multiple of 3, and then the leftover crap. Cube root of 27 is 3. Can't do anything with this. Can't do anything with this. Cube root of x or y cubed is y. Cube root of z cubed is z. And then cube roots of 3x squared z. All right, last problem. I got to slide over so my big bald head doesn't get in the way. So the nice thing is 81 is a 4th, so we'll just leave it. Actually, there's nothing to do with this one because I'm going to rewrite it exactly as it is there. 81 already is a 4th. The 4th root of 81 is 3. Can't do anything with x squared. Can't do anything with y cubed. Z to the 4th is z. 4th roots of x squared y cubed. All right, that wasn't bad. All right. So we're going to add, subtract, multiply. Add, subtract, and multiplying. I guess we're not dividing. Dividing is the same thing as multiplying, sort of. Not really. The key is that you want to simplify all radicals. So the other thing we're going to talk about is when you add, you have to add and you got to treat variables. You got to treat radicals like variables. They all have to. They have to have the exact same thing. Then you can add or subtract them. Multiplying is a different beast. You know, for example, I can add x plus 3x and get 4x. I can't add x plus y. But I can multiply x times y. But I can't add them. There's nothing to do there. We just leave them. All right, so treat them as variables. If this was 3x plus 4x here, you'd be like, oh, that's just 7x. All right, same thing with radicals. 3 square roots of 3 plus 4 square roots of 3 is 7 square roots of 3. Just like the variable's not going to change when you're adding and subtracting, the radical doesn't change either. 2 cube roots of 5 minus 3 cube roots of 5 is negative 1 cube root of 5. Just treat them exactly the same way. Multiplying outsides, multiply the insides. In other words, you're going to multiply the numbers together that are outside the radical and then multiply the things that are inside the radical. So 2, this we're going to use the distributive property clearly, right? So 2 times 3 is 6. The square root of 3 times the square root of 6 is the square root of 18. Then we're going to multiply here. 2 times negative 3 is negative 6. The square root of 3 times the square root of 3 is the square root of 9. But wait, we're not done. See, when you multiply, you're always going to have a little bit more work to do. Okay? because this can be simplified, and of course this can be simplified. This is easy. This is just 3. So I know at the end of this thing I'm going to have a minus 18. But this is a little bit more interesting. So let me put this right over here. 6 square roots of 9 times 2, right? 9 times 2. Remember, cut it in half. All the stuff we learned yesterday or last couple of days about simplifying radicals. Square root of 9 is 3. So this is 18 square roots of 2. So our answer is 18 square roots of 2 minus 18. All right, we'll do it again. See, these are both in cubes, so they can be multiplied. So if I multiply this cube times this cube, I get the cube root of 250. Not done yet, because I got to look for a perfect cube. And we did 250 yesterday. Cut it in half, you get 125. Oh, 125 is on my list. So I'm going to rewrite this as the cube root of 125 times 2. Well, what is the cube root of 125? It's 5. So this becomes 5 cube roots of 2. Right? Because the cube root of 125 is 5. So you always got to look to see if your answer is in simplest form. All right, let's go practice. So when we multiply, we just multiply. Now, this can get a little funky cold Medina here, but let's just do this. Let's see. What is 18 times 8? I don't even know. This problem becomes a little bit more tricky when you actually multiply. But 144, that's not too bad. So this becomes 144 square root, or x to the, let's see, 3 and 5 is 8. X to the 8th. Add those exponents up. All right, so, well, this is a perfect square, and this is a perfect square. It's already written as a, or as an even, so we're good. What's the square root of 144? It's 12. What's the square root of x to the 8th? X to the 4th. So that is really that. All right, let's try another one. All right, let's do this. So we're going to multiply 5 times 2. So that's 10. Cube roots of negative 32 times a half. Well, that's just negative 16. A times a squared is a cubed. B to the 4th times b is b to the 5th. All right, so now we have to write this up as perfect cubes and not perfect cubes. But we have to be careful. Alert, alert, we've got a negative. Look, kids, negatives in Algebra 2 are the bane of your existence. You have to learn to deal with them. The cube root of a negative is negative. It's not I. I is only for equal to the square root of negative 1. It is only for square roots. So don't mess with i's and cubes. They don't go together. I cubed that. I don't know what I mean. So 16 is not a perfect cube. So we cut it in half. 8. Oh, 8's a perfect cube. So we're going to rewrite it as negative 8 times 2. A cube is a perfect cube. And then b to the 5th, we're going to write it as a multiple of 3 and then not a multiple of 3. Or whatever's left over. All right, so the cube root of negative 8 is negative 2. So negative 2 times 10 is negative 20. Cube root of a cubed is a. Cube root of b cubed is b. And then I got, what do I have left over? I got the cube root of 2 b squared. Moving on. So when we're trying to add these suckers up, right, we can't add them up. Like, there's going to be somebody on the test. I'm telling you right now, there's going to be somebody on the test. And I'm going to blow my top. That's what happened. What's what happened to my hair, right? I got so angry, my hair fell out. Someone on here is going to go 6 minus 3 is 3 plus 8 is, that's like 11. And then they're going to start adding the radicals. You can't do it. These radicals here have to be exactly the same, or you cannot add them. I mean, exactly the same. Just the radical. I don't care about the number. So we got to play with it. So we're going to deal with these individually. So 6, 24 is 4 times 6. The square root of 4 is 2. So this is 12 square roots of 6, minus 3. Now, 96 is a little bit troublesome. Cut 96 in half, you get 48. So the first perfect square under 48 is 36, doesn't go in. Then 25 doesn't go in. 16 does. 16 does. If you check 16, it goes in 6 times. So 16 times 6. Square root of 16 is 4. So this becomes minus 12 square roots of 6 plus 8 times 54. Cut in half, you get 27. Now 27 is a perfect cube, but is not a perfect square. So the first perfect square under 27 is 25. That doesn't go in. 16 doesn't go in. 9, yes. How many of y'all remember 9 times 6? So this becomes, square root of 9 is 3, so this is plus 24 square roots of 6. And now notice that they all have the exact same radical. Now they can all be put together. Now that's a little weird. You got 12 square roots of 6 minus 12 square roots of 6. They just go away. And then there's your answer. 24 square roots of 6. Operations with complex numbers. I will be right back just so we can see what we do there with those operations. So first and foremost, your first question should be, what is a complex number? Like everything you're doing is complex. All right, look, once you got past 10, the numbers got complex. Don't even understand anything past 10. That's a problem. All right, let's talk about complex numbers. So we know that if we had like, we've talked about real numbers, 5, 8, 7, 6, 12, 17, 1/2, 2/3, whatever. The real numbers, square root of 5, whatever, weird numbers, real numbers. And then we got imaginary numbers, like, we decided to make things a little bit more difficult and added this thing called I. Well, if you take real numbers and you add in I numbers, you get a complex number. Let me give you an example, and then I'm going to show you how we refer to them. An example of a complex number might be something like 4 minus 3i. It has a real part, and it has an imaginary part. Now, by real, I hope you all know that real numbers, real numbers are whole numbers, natural numbers, integers, and the rational numbers, right? We've talked about that many times in the past in your math. We don't want to go through that. So this could be the square root of 5 minus 3i, whatever. So when we're dealing with it in the world, it'll always say, put your answer in A plus or minus BI form. So anytime you see the words plus or minus BI form, we're talking about complex numbers. The good news is complex numbers you're going to deal with very similarly that you do with as radicals. But there's some common mistakes made. The one thing you really want to be on the lookout for is I squared. Now, I don't even remember all these common mistakes. We'll go through them in a minute. This one I don't even remember. There is no common mistake made on this one. So, and this one I don't really even need the parentheses. I could just rewrite this. There's no number to distribute. There's no negative here. So it's really 2 plus 5i plus 7 minus 2i. And then, so what we'll do is, first things first, we'll combine the real parts. 2 plus 7, that's 9. And then we'll combine the imaginary parts, 5i minus 2i, and that is plus 3i. I don't even know why I put this here. I don't think there's common mistakes made on this one. Clearly the common mistake made on here is not distributing the negative. So be careful with that negative. So this is going to be 6 plus 3i minus 4 plus I. And then we combine 6 minus 4 is 2. 3i plus I is plus 4i. And this would be a complex number. Anytime you write a complex number, the real part should come first and the imaginary part should come second. It's just how it works. All right. Now, the common mistake on this one is forgetting that I squared equals -1. I will tell you right now, if you're going to start multiplying imaginary numbers, I squared is going to come up sometime, and you have to replace it with -1. So we are going to double distribute this because it's one set of parentheses to the other, unless your teacher calls it FOIL, and we're going to do that as well. So 2 times both of these things. So 2 times negative 5 is negative 10. 2 times 2i is plus 4i. Now we're going to distribute the I. So I times negative 5 is negative 5i. And I times 2i is plus 2i squared. And this is where you're going to make the common mistake. This thing right here, you got to remember, is really 2 times negative 1. Because I squared is negative 1. So in other words, anytime you're multiplying by I squared, you're really multiplying by negative 1. In other words, you're just changing the sign. So instead of this being plus 2i squared, it's really just a minus 2. Right, minus 2. So we've got minus 10 and minus 2. So that's minus 12. 4i minus 5i is minus 1i. Now the cool thing about all this stuff is you can do this crap on your calculator as well. Let me get over to the dumb machine. I'm just going to show you with this last example, which was really hard. 2 plus, don't forget you got to use the I that's over here. It's the imaginary I that's in the pi menu thing. Negative 5 plus 2i. And just press enter to get negative 12 minus I. So it'll check it. Yeah, if you don't show this work, though, you get nothing. You get nothing. All right, let's practice. Let's work on some practice. So in order to be able to combine, these two radicals have to be the same because I'm adding and subtracting. Since I'm adding and subtracting, they have to be exactly the same. So we've got some cleanup work to do. So you're going to have to practice with your cubes. This is 8 times 3. What is the cube root of 8? 2. So this becomes 4 cube roots of 3. Minus, now we'll do this one, 5. Now, you should probably know that 125 goes in that. Hopefully we've gotten to a point where you know that 125 times 3. What is the cube root of 125? It's 5. So this is minus, what's 5 times 5 is 25 cube roots of 3. So now you'll notice you have the cube root is exactly the same. So we'll just say, okay, what's 4 minus 25? It's negative 21 cube roots of 3. All right, now we're at square roots. So now we're dealing with square roots. So 48, cut it in half, 24. Perfect square into 24 is 16. Remember, it goes in 16 times 3. I'm just going to finish with this one, 4 square roots of 3. So what I'm hoping for is these all have a square root of 3 in them, because that would make my life easy. So I'm going to go 27 times 9 times 3. Oh, 9 is a perfect square. 9 times 3. The square root of 9 is 3. So this becomes 3 square roots of 3. Plus 12. 12 is 4 times 3. So I'm in pretty good shape. 4 times 3. Square root of 4 is 2. And now that these radicals are all radical 3, I can just combine them. 4 minus 3 is 1. 1 plus 2 is 3. Square roots of 3. All right, then they get more complex. Start adding start adding numbers. So 8's a perfect, well, there's nothing really to do with that one. This one right here I can change. Oh, this is multiplying. Oh my God, I just realized they're multiplying. I don't have to change them. Multiplying is actually easier. You just multiply and simplify. It's actually much easier. So adding and subtracting is the pain in the neck. So I can multiply these two together because as long as they're both cubes. So this becomes the cube root of 24x to the 6th. But then you got to simplify. You can't just leave it. You got to simplify. So cube root of, hopefully you know 8 times 3 is 24. And x to the 6 is already a perfect cube. The cube root of 8 is 2. The cube root of x to the 6 is x squared. Remember, we're looking for groups of 3, not groups of 2, groups of 3, because it's a cube. And then, little space, cube roots of 3. All right, look at these. We got 18, we got 75, we got 45, and we got 50. Now, please don't be the person that adds all that up and go, "Mr. God, there's my answer. I done got that answer right." So, yeah, don't do that. Don't be that person. All right, so 4 square root of 9 times 2. What is the square root of 9? It's 3. So this is 12 square roots of 2. We get to the next color. Plus 2 square root of 25 times 3. Square root of 25 is 5. So this becomes plus 10 square roots of 3. Now those two can't be added together because they don't have the same radical. Minus 2 square roots of 9 times 5. Square root of 9 is 3. So this becomes minus 6 square roots of 5. Okay, this is turning out to be a disappointing question because none of that stuff can be combined so far. Minus 4 times the square root of 25 times 2. Square root of 25 is 5, so this becomes minus 20 square roots of 2. So the only two things that can be combined are this one and this one because they both have radical 2. Everything else just kind of comes along for the ride. So 12 minus 20 is negative 8 square roots of 2 plus 10 square roots of 3 minus 6 square roots of 5. Let's deal with some imaginaries. Actually become the easier stuff, quite frankly. You just got to remember that I squared equals negative 1. So distribute, you get negative 36i. Distribute again, you get minus 20i squared. Now you got to remember that this is really just negative 1, so you're multiplying by negative 1. So 20 times negative 1 is really positive 20. So this is negative 36i plus 20. Now I did that, but I realized that this should come first if you want to put it in a plus bi form. So we'll do 20 minus 36i. You should get in a good habit of putting it in a plus bi form. All right, we've got to double distribute. So 2 times 2 is 4. 2 times negative 2i is negative 2i. I times 2 is plus 2i. And then I times negative I is negative I squared. Oh, that's going to get a little funky. Well, first, these cancel because positive 2i and negative 2i cancel. And then this is really minus, and then what's I squared? Negative 1. Well, what's minus negative 1? That's really plus 1. So the answer to this problem is really just 5. Moving on. All right, so we just got a plus. If you see a plus here, you're like, woohoo! Simple. 3 plus 8 is 11. There's no distributing, even though there's parentheses, because there's no number out front. And then negative 4 and negative 2 make negative 6. That's easy. Let's distribute here. We get I squared plus 7I cubed. All right, we got some issues. I squared is negative 1. So that's easy. Plus. So this 7I cubed, I can rewrite it as 7I squared times I. Well, what is I squared? It's really negative 1. So this becomes minus 7i, or negative 1 minus 7i. Just be careful. Again, all I did here was go, okay, 7, I took the I cubed, and I wrote it as I squared times I. Well, I squared is really negative 1. So I multiplied here, and then 7 times negative 1 is negative 7. All right. Play a little bit more. 1 times 3 is 3. 1 times I squared is plus I squared. I squared times 3 is minus 3I squared. And then I squared times negative I squared times positive I squared is minus I to the 4th. And by the way, this is the really hard way to do this problem. 3 plus negative 1 minus 3 times negative 1. And then do you remember that I to the 4th is really 1? So minus 1. So this becomes 3 minus 1 plus 3 minus 1, which It's really 6 minus 2, which is 4. Now, watch this. If you notice something right away, it makes this problem about 100 times easier. Isn't I squared negative 1? So isn't this really just 1 minus negative 1 plus 3 plus, or times 3 plus negative 1 here? Well, this becomes a big plus. So this is really just 2. And this is 3 minus 1, which is just 2. 2 times 2 is 4. Oh, that was so much easier. Distribute the negative. So 6 minus I minus 12 minus 8I. Combine them. 6 minus 12 is negative 6. Minus I minus 8I is minus 9I. All right, let's do some more practice. Oh, this one's a little funky. This one's pretty cool. What's the square root of x times the square root of x? The square root of x times the square root of x is really the square root of x squared, which is just x. So anytime you multiply a radical times itself, it just becomes itself. So the square root of x times the square root of x is just x minus 6 square roots of x plus 6 square roots of x minus 36. Well, these cancel, and I get x minus 36. This one's kind of a pain. 5 square roots of 2 times the square root of 2. So this isn't too bad. The square root of 2 times the square root of 2 is just 2. It really is the square root of 2 times the square root of 2 is really the square root of 4. But isn't the square root of 4 just 2? All right, here we go. 5 square roots of 2 times 4 square roots of 6 is plus 20 square roots of 12. All right, now we're going to do the inside stuff. So let's see. Negative times this. So this is negative 3 square roots of 12. Minus 12. And what's the square root of 6 times the square root of 6? It's just 6. I mean, I can write it as the square root of 36, but that's kind of boring. So let's see what we got here. 10. These two can be combined. So plus 17 square roots of 12 minus 36. Well, you might think you're done, but believe it or not, we got like 2 or 3 more steps on this sucker, because this sucker's a pain. So, a couple things. This can be combined now with this. So we get negative 26. And then we got this 17 square roots of 12. Well, that's really plus 17 times. Isn't there a perfect square that goes in 12? You always have to look to simplify. That's the kind of a pain in the neck that radicals are. It's really, and then this is just 4 times 3. And what is the square root of 4? 2. So my final answer is negative 26 plus, multiply these two together, 34 square roots of 3. All right, moving on. Now, you would love to add these things up, but the radicals are not the same. You can't do anything with this, so that's kind of nice. There's really nothing to do. But with this one, we got a little bit of work to do. And let's see. Cut 40 and a half, you get 20. First perfect cube under 20 is 8, and 8 goes in. And isn't that weird that it goes in 5 times? What is the cube root of 8? It's 2. So I have 2 cube roots of 5 plus 6 cube roots of 5. And now that they both are cube roots of 5, I can put them together and get 8 cube roots of 5. All right, back to square roots. We're back to square roots. The square root of 150, so that's going to be 25 times 6, or 5 square roots of 6. Now that means this one probably has a 6 in it. What times what gives you 54? What times 6 gives you 54? 9. And the square root of 9 is 3. So this is minus 6 square roots of 6. So 5 minus 6 is negative 1 square roots of 6. You do not need the negative 1 if you don't want it. Squared just means write things twice. I'm going to write this out. 2 minus 3 square roots of x. I know I'm moving quickly, but you can always pause the video, stop, slow down, go back, see what I said. All right, 2 times 2 is 4.
2 times negative 3 square roots of x is negative 6 square roots of x. Multiply these two together, I get negative 6 square roots of x. And then negative 3 times negative 3 is positive 9. And then what is the square root of x times the square root of x? It's just x. It's really the square root of x squared, but that's x. All right, so we got 4 minus 12 square roots of x plus 9x. All right, let's deal with this one. Now, I'm hoping that these all, oh, what the heck's going on? This is a fourth root. I'm hoping I'm going to put those two together. Square root of 4 times 3, so this becomes 2 square roots of 3 minus, well, what it is, I think 729 is on our fourth list, right? By the way, just in case you're wondering, control caret button, put a 4 there, and then 729 is just, oh, I'm looking for a perfect fourth that goes into 729, and that ain't it. This calculator does everything for you. So let's do 729. Ooh, what had happened? All right, let's go back into calculator mode. Let's take 729. It's not a perfect fourth, apparently. I don't know what I was thinking of. Whatever. What are our perfect fourths? Divided by... Ooh, I got to show you that trick. There's a trick to this. Let's go 81 probably. 81's a perfect fourth. 81 times 9. 81 times 9. So this is, oh, what a stupid problem. I don't know why I put this one in here. 81 times 9. Why did I do that? This is a stupid question. Don't even bother with it. I mean, let's just add in the square root of 3. Hold on a second. Okay. I just looked back through some of my notes to see why I put this one in here. I sort of know why. I don't know why. This would be more like a pre-calculus kind of a question right here. Because here's what it is. It's the fourth root of 81 times 9. Okay. So the fourth root of 81 is 3. So this is minus 3 fourth roots of 9 plus 3. And I'm going to combine these two. So this is 3 square roots of 3 minus 3 fourth roots of 9. Now, for anybody that's in some seriously upper level mathematics, you're going to find out that the fourth root of 9 is really the same as, I'm not going to bother with it. Let's just leave it. Let's just leave it. We're going to leave it just like that. You ain't ready for it. Don't worry about it. I shouldn't have put it on there. I don't even know why I did it. Don't bother. Don't bother. We're multiplying. So we're going to multiply. Multiplying is easy. We like multiplying. So 4 times 12 is 48. X to the 5th. Y. Z to the 8th. All right. So let's see. Looking for perfect cubes that go into 48. We know that's 8 times 6. X cubed, X squared. Y. Z 6, Z squared. Cube root of 8 is 2. The cube root of x cubed is x. Cube root of z to the 6 is z squared. Cube roots of 6 x squared y z squared. Boom, shabam, done. Oh man, what the heck? Adding and subtracting again. All right, no big deal. This one looks really, really crazy. You'll never get one on a test like this, but whatever. Let's play around with it. All right, so 16 is a perfect fourth. So we're going to be 16 times 2. X to the 4th, x squared. Let me finish up with this one. Square root of the fourth root of 16 is 2. The fourth root, 2 times 2 times 2 times 2. So I end up with 2. The fourth root of x to the fourth is x. So I end up with 2xy, because the y is on the outside. Fourth roots of 2x squared plus x times. We just talked about 81. Cut 162 and a half, you get 81. 81 is a perfect fourth. 81 times 2. X squared we can't do anything with, but y to the fourth we can write as, oh, it's y to the fourth. That's good. All right, let's see what we got here. The fourth root of 81 is 3, so I end up with plus 3x, and the fourth root of y to the fourth is y. So you had the 3 out, the x is already out here, so we got 3x, y, and then fourth roots of what's left over is 2x squared. Well, you'll notice that this x, y, fourth roots of 2x squared, x, y, fourth roots of 2x squared is all the same. So this ends up being 5x, y, fourth roots of 2x squared. Don't worry, you'll never, ever get anything like that. That is the same as that. So this is 12 fifth roots of x. Kind of a stupid question. This is 6 cube roots of 5. So plus, we can't add these up. Isn't 625 a perfect fourth, kids? What happened to my calculator? Oh, I got so mad I got angry. Well, 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So this is plus 5. There he goes. That's the answer. That's all she wrote. I don't know why I brought the calculator out. So I started with some, I ended here with some crazy ones, and then the last two are like a joke, really simple. So whatever. All right, kids, catch you on the flip side. Radicals. Adding